All right. Hello, everyone. Hope you all are doing well. I'm in Virginia. It's very warm here. It's been 70 degrees some days. It's going to be 80 degrees sometimes next week. It also gets a little bit cooler. Yeah, so hope you all are staying safe. I don't know exactly what to think about everything that's happening, but I guess we'll get through the rest of the semester together. So like I said in my email, cancel the second midterm. It'll just be a couple of these videos and homework assignments like we've been doing. Fortunately, you all are used to submitting homework electronically already. Um, and the final exam will be take home. We'll talk about that more later. So uh, this video is starting with the material we were talking about a week or a week and a half before spring break. That's when we started fractions previously, but so many of you all were out of class anyways, I figured I would just start fresh and have a complete set of virtual lectures on the stuff about fractions you all need to know. So the technology I'm using to make this video is Microsoft PowerPoint. It's actually capable of doing stuff like this. It's pretty neat. If you want to hear more about it, let me know. It has like a pen tool and stuff like that. So yeah, so it'll be YouTube is where all the videos are. Cool. So let's go on and talk about what we need to talk about with fractions, and just any questions, concerns, anything, just email me. Okay, so this first video is about the basics. What are fractions in the first place? And so we've already talked about this, but just for the sake of completeness and consistency, let's just do a video about it. Okay, so like we said in class, a fraction basically represents a measurement. The measurement you get when you divide a whole number by a whole number. For example, I have 1 cup of flour. I give each of my 9 friends an equal amount of flour. How much flour does everybody get? 1/9. That's kind of like the definition of the number of the fraction 1/9 in the first place. The definition of the fraction 1/9 is it's the measurement you get when you split 1 evenly into 9. And here's the little picture of it, right? We can see this whole big circle represents 1 cup of flour. And so how do we visualize 1/9 cup of flour? We split the 1 cup of flour evenly into 9 pieces. Cool. Yeah, I think we're all pretty familiar with this. But it's worth reflecting for a minute. What's kind of like the fundamental definition of a fraction? What does 1/9 mean? This is what it means. How much everybody gets when you split 1 evenly into 9. And so fractions and division have a lot to do with each other. Going back to the next, I'm not allowed to go back to the next slide. But kind of like 3/4 and the quotient 3 divided by 4, they kind of mean the same thing. It's just that we think of 3/4 as the number or the measurement, how much flour everybody gets when you split 3 cups of flour among 4 people. And we kind of think of, the quotient 3 divided by 4 as a process. We think of 3 divided by 4 as representing the process of splitting up 3 cups of flour among 4 people, whereas 3/4 represents the measurement, how much flour does everybody actually get. So they have a ton to do with each other, but they're kind of conceptually different things a little bit. Maybe another way of phrasing it, what is 3/4? 3/4 is the number that splits 3 evenly into 4 pieces, in the same way that 1/9 is the number that splits 1 evenly into 9 pieces. 3/4 is the number that splits 3 evenly into 4 pieces. This is another way of thinking about fractions. And so we have some more pictures of this on the next slide. Trying to illustrate, 3/4 is the number that splits 3 evenly into 4 pieces. So we have right here 1, 2, 3 cups of flour represented by these 3 circles. And we have these colored segments, blue, red, purple, and green. Each of these segments have size 3/4. I think we can see from the picture. And I think we can see also that kind of these 4 colored patches are splitting the 3 cups of flour evenly into 4 equal pieces. That's what this is illustrating. I hope this is making sense. Just if we have 3 cups of flour we split into 4 piles, how much is going to be in each pile? 3/4 of a cup of flour. And we can see this visually too. If we split 3 units evenly into 4 pieces, each of those 4 colored pieces are going to be of size 3/4, just like in the picture. Cool. And so one of the very important things we had mentioned earlier is that it's possible for 2 fractions to be written differently on paper, have different numerators and denominators, but that still they represent the exact same measurement. And so the example we talked about in class was that 1/2 is equal to 2/4. So unfortunately this video is covering a little bit of my diagram at the bottom, but I think you get the point. This blue part of the picture represents 1/2. This is 1 unit, 1 cup of flour split evenly into 2 pieces. Each of the 2 pieces has size 1/2. And on the bottom, we have the green part represents 2 cups of flour split evenly into 4 pieces. Each of these 4 green patches represents an equal partition of 2 cups of flour into 4 pieces. But we can see that each of these little segments that I'm highlighting here with my dot, each of these little segments, they're the exact same size. 1/2 and 2/4 are the exact same measurement. They are the exact same number, in fact. And that's why we say 1/2 is equal to 2/4, because they are literally the exact same measurement. And so that's the moral of this slide. 2 numbers can be written differently, yet represent the exact same measurement. And we can see this from the diagram. If I have 1 cup of flour and I split it into 2 piles, or if I have 2 cups of flour and I split it into 4 piles, in either case I'm putting the exact same amount of flour in each pile. These are the exact same numbers. And here is everything I just said in writing form. So I guess I'm getting used to this technology a little bit. Apparently I'm not allowed to go backwards in my slides, and it'd be nice if I could preview the next slide a little bit, but hopefully I'll streamline this a little bit more in the future. Cool. Cool. Okay, and yes, we have some more things to say about equivalent fractions. There's going to be a way to tell using math and numbers whether or not 2 fractions are equivalent. And we noticed that 1/2 and 2/4 have a relationship. Basically, 2 is 1 times 2, 4 is 2 times 2. In other words, the fraction 1/2, we multiply numerator and denominator by the same number. We multiply numerator and denominator by 2, and we get an equivalent fraction. And so this is true in general. If we have a fraction like 1/2, we multiply numerator and denominator by the same number, we're going to get an equivalent fraction. For example, trying to draw with my trackpad here. Oops, 8/16. For example, 1/2, multiply numerator and denominator by 8, you get 8/16, very poorly drawn 6. And this is always true. Take a fraction, multiply numerator and denominator by any number, you get an equivalent fraction. And this kind of makes sense, right? 1/2 represents 1 split into 2 groups. 8/16 represents 8 cups of flour split into 16 groups. How much flour is in each pile? So we're making 8 times as many groups, but we're also splitting into 8 times as many piles, so it's going to be the same measurement still. And also, what this slide is saying, we can also divide numerator and denominator by the same number if we're allowed to. This is kind of going backwards. We're able to multiply numerator and denominator by the same number. Going backwards, we're able to divide by the same number and get the same measurement. So for example, 6 and 8 are both divisible by 2. And if we divide numerator and denominator by 2, which would give us 3/4, we get an equivalent fraction. Good to know. And we talked a little bit in class earlier about simplifying fractions. Simplifying fractions just means dividing numerator and denominator by common factors until you can't anymore, until it's in least terms is what we call a fraction that can't be simplified anymore. Fraction in least terms. I'll make a little vocab list for you all at some point. But so for example, 6/8, divide numerator and denominator by 2, we get 3/4. And we can't simplify this fraction 3/4 any further. We can't, there's no more factors we could divide numerator and denominator by to get a simpler fraction, just because the only factors of 3 are 1 in itself. It's a prime number. And the only factors of 4 are 1, 2, and 4. In other words, 3 and 4 don't have any common factors besides 1, so there's no way we could simplify this anymore by dividing numerator and denominator by the same thing. And so it's good to, review for yourself a little bit. How do you simplify a fraction? Well, you just keep dividing numerator and denominator by common factors until you can't do it anymore. For example, say we start with 24/48. We can divide the top and bottom both by 3. 24 and 48 are both divisible by 3. That gives us 8/16. And now maybe we notice 8 and 16 are both divisible by 4. 8 divided by 4 is 2. 16 divided by 4 is 4. And then finally we can divide top and bottom both by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And of course we could have done this faster in the first place. We could have just divided the original fraction, divided top and bottom both by 24, but it's okay. We don't, either way works. And so we'll say one more thing, and then we'll move on to the next video. An important fact about fractions in general is that if you have two fractions, you can change them into two equivalent fractions with the same denominator. And this is going to be fundamentally what helps us figure out how to do fraction addition and subtraction. So what do I mean by this? For example, let's just say somebody hands us the fractions 1/4 and 2/5 and tells us change these two fractions 1/4 and 2/5 into equivalent fractions with the same denominator. So what did we say earlier? We said to get an equivalent fraction of a given fraction, you can multiply numerator and denominator by the same number. That gets you an equivalent fraction. So we have an idea here. The idea is whenever you're handed two fractions and you want to turn them into two fractions with the same denominator, what you should do is multiply each fraction by the top and bottom of each fraction by the denominator of the other. So I think this is just clearest to see with an example. The fractions are 1/4 and 2/5. So 1/4, we want to multiply top and bottom by the denominator of the other. So we multiply top and bottom of 1/4 by 5. 5 is the denominator of the other fraction. So 1 times 5 is 5. 4 times 5 is 20. So 1/4 is equivalent to 5/20. And the other fraction, 2/5, we're going to multiply top and bottom by 4. 4 is the denominator of the other fraction. So 2 times 4 is 8. 5 times 4 is 20. What was the point of all this? It turned our original two fractions into two equivalent fractions, 5/20, 8/20, two equivalent fractions with the same denominator. This is going to be important later, but this is just the nifty idea. Multiply by the denominator of the other, well, that gives you two fractions with the same denominator. They both have the denominator 4 times 5. And that's it. It's nice. Cool. So we'll be moving on to the next video.